sometimes receivers are involved in transfer. Good morning. Thank you for joining us here today. I'm Liz Goldsmith from the TIA Single Pair Ethernet Consortium, and we have a great portfolio of speakers coming up. Our first is Zeph Freeman from Microchip Technology, who is speaking on 10 days T1S, bringing Ethernet to the edge for industrial and building automation. In this session, attendees will learn how 10-base TS is transforming industrial and building automation by extending Ethernet connectivity to the edge. With single-pair Ethernet cabling and multi-drop technologies, 10-base T1S simplifies network design, lowers costs, and enables seamless integration of sensors, actuators, and control devices. I'd now like to turn this over to Zeph, who is the Senior Business Manager of Development and Marketing at Microchip. He has more than 30 years of experience in high-speed semiconductor connectivity. Zeph?
Thank you, Liz. Good morning, everybody. Glad to be here. As you mentioned, my name is Zeph Freeman. I'm with Microchip Technology. We are investing a lot in 10-base T1S solutions. And I'm going to talk to you today about how you can bring Ethernet to the edge for industrial building automation using 10-base T1S. So first of all, this is the agenda for today. I'll talk to you what is single pair Ethernet? What do I mean by bringing Ethernet to the edge nodes? What are some of the requirements of an edge node? How does 10-base T1S work in edge nodes? Some examples, and then a conclusion. So when we talk to SPE stands for single pair Ethernet. It's very scalable, lots of scalability. The thing about SPE single pair Ethernet is it's only at the 5 lane. So layers 2 through 7 remains the same for Ethernet, no matter whether we're talking 10-base T1S, 10-base T1L, 100-base T1, 1000-base T1, or 2.5 10 T-base T1. And so it's scalable because it's only the speed of the fire that's changing. And then that allows you to have very common software stacks, as well as removing requirements for very expensive and dedicated gateways. So like with legacy systems with Ethernet and Field Bus and UART, these are all legacy systems that have worked very well. But they are proprietary in some cases expensive. So what we're trying to do here is get the entire network Ethernet. So that's what the Ethernet team has come to do now. So why Ethernet and why stainless? Because Ethernet has been around for a very long time. I think Ethernet was developed in the 70s. I think IEEE adopted Ethernet in 1983. So Ethernet is basically physical layer, the data plan. We're focused on EL2.3. Ethernet also provides security, connectivity, IPsec, XDAN, also synchronization, which is PTP, that is driven off of the IEEE 1588 and IEEE ALG.3, .2.1 AS standards. And also provides for remote control protocols for sensors and for actuators, and also streaming protocols for video and audio. And again, there's no need for a very expensive gateway because you're basically connecting to what we have today as a common switch. So that allows developers to use their value-added time working with other resources. So this, I apologize for this, it's very small. But basically what it shows at the top is some of the applications that you can address when the band is using H21S. So there's relevant for transportation, for building, factory automation, and so on. And then the different color bars, the dark green bar basically says that as you go higher and higher in bandwidth with 10-base T1S, and also with your cable reach, that determines whether you want to use a shielded twisted pair cable or an unshielded twisted pair cable. So the lighter bars is depicting a unshielded twisted pair cable, whereas the darker bars already shielded just from cable. So as you can see, as you go right in cable reach, you may want to move to a shielded cable for better signal integrity. And as you go higher and higher bandwidth, you may want to move to a shielded shielded cable for better signal integrity. So what is 10-base T1S? 10-base T1S, it is governed by 802, IEEE 802 bound 3, gas 2282, clause 147. It is a 10 base means 10 megabit per second. T1 means one twisted pair. So that's where T1 comes in. And the S means short. And you hear a lot of people say also multi-drop network. I'll talk more about what I mean by multi-drop network. And then also 10 base T1S provides for what's called binary collision avoidance. So unlike other protocols like SPS, where you actually have collisions and timeouts and things like that, but with physical layer collision avoidance, it actually ensures that there are no collisions on the network. And for physical collisions, and also designating what we call a round robin fashion. So each node has a strobe and sequence to transmit data. And graph over to the right, the rest of the show that from the data link layer up, which is layers 2 through 7, this is not test. What's test with 10 base T1S is the 5-layer only, which is layer 1. And we're adding PLCA to the for as avoidance. And I'll talk about that. So when we talk about bringing Ethernet to the Israel, Ethernet to the Israel has been there for a while. But in the past, it's always been, you've had very expensive, high-performing edge servers, IoT servers, things that made sure that the edge nodes were attached, no matter what type of edge node is capable of attaching that edge node to the server. So in many cases, the servers were very high-end, very high performance with high-end SoCs. And the edge nodes have always been small and inexpensive devices like sensors and actuators that connect to the edge node, but since these gateways had to encompass all, they were very high performing and kind of had to encompass it, no matter what type of edge node that is connected. So therefore, it will become very expensive. And what we're showing today is that 10 base T1S enables low-cost devices to Ethernet, and there's no need for gateways. You can use a simple tools. I had a demo that I was going to show with a video, but we don't have the capability to show video here today. You will get a copy of this presentation. In this presentation, the link is there, so you can click and watch the video. And also, if you stop by our kiosk in A2, I have a very similar demo to this runner in a kiosk. But basically, what this demo is showing is sensors and actuators connected via Ethernet, 7 nodes, and this we've got a 10 base T1S pressure sensor, temperature sensor, door actuators, window actuators, different nodes showing different inputs and outputs, proximity sensors, light sensors, and you're seeing where these digital inputs are converted to from the physical world to motors and bands and displays, it turns that into physical outputs. So that's what we're showing with this demo, as you've been able to see it. But anyways, again, stop by the booth and you'll be able to see a very similar demo to this. So when we say multi-drop, what we mean is that you've got a switch and you've got several nodes hanging on the bus. And there is no need to have several switches on the network. You can basically put these nodes on the same bus in series, and that forms the multi-drop. And the PLCA is, binary collision avoidance is what controls preventing collisions as well as allocating the bandwidth along the bus. So it also provides for mixing of the different lines on the bus, and there's no need for a star topology. So you can have basically just an inline series topology. And so you see the graph over the pictorial to the right where typically you would have a switch with point-to-point solution, switch going to an end node, by doing multi-drop, it eliminates the need and reduces costs. So you can see in this diagram, I'm going from 6 connectors down to 3, maybe 4 connectors. And I'm also reducing the cable length because I'm now multi-dropping the cable. Therefore, you don't need as much cable. So especially for like automotive, for example, where weight is critical, you can reduce the weight of the wire because you're shortening the distance of the wire. You can reduce the number of connectors and save cost because they are in series. So these are ways that chip-based want us to save you costs, make your systems more efficient, and also it enables power over data line. But I believe IEEE is renaming the SPS tool. They're renaming that to multi-drop power over Ethernet. I believe it's the term that's going to be used and appreciated. But anyways, this is just showing that chip-based T1 has can lower cost and also reduce complexity, system complexity. So how does PLCA work? Finally, collision avoidance, basically what it does is the end node 0 sends a beacon, which is the B, and then there's a period of silence, and then there's a transmit opportunity for end node for node 0. After node 0 transmit, there's a period of silence, then transmit opportunity for node 1, transmit opportunity for node 2. So it does it in a round robin fashion, and then the bus starts all over. So it repeats that, and it ensures that there's no collision because each node has its turn to transmit. So when we talk about edge nodes, what are some of the things that we need to consider? Of course, you need to consider there's some nodes that may want to require additional bandwidth, and some nodes may be even more critical on latency. And then there may be some nodes that don't want to transmit at all. So then you ask, can other nodes acquire that bandwidth if other nodes are not transmitting? And I'll explain all of that to you later on the next slide. But yes, that is all possible. And then also you must consider time synchronization. So a clock must always be within the network and maintained. And the clock also determines when was data captured and what was the event that was happening at the same time. PLCA also provides what's called burst mode. So I mentioned, what if a node needs more bandwidth? Burst mode is a way to provide more additional bandwidth to any particular node. So it works the same as PLCA because it is PLCA burstless. But basically what happens is the beacon is sync, there's a period of silence, and then, for example, node 1 has a transmit opportunity along, but it also sends a commit, which tells node 2, don't transmit because I was going to send more D. So it sends a commit to transmit number 2. Then it also can send a commit to transmit number 3. So therefore, node 1 has transmitted 3 times before node 2 ever had a chance to transmit. So that's what's called burst mode. Now, this is very tricky, and the designer has to provide for that. Burst mode is provided for in the standard NO2.3. 10.1S does provide for burst mode, but you have to architect it properly to ensure that you don't get in trouble with your bus singers. So, Microchip, not only do we support burst node, but there's also, we design our chips with multiple IDs. So the reason that's important is because in many cases, for example, like streaming audio, even though you may be able to use burst mode, audio may not all be coming in burst, but you may want to transmit immediately once you receive it. So what a multiple ID will do, for example, you can see in the diagram, it's the design time is really low. But anyways, you can see in the diagram where there's transmit opportunity 1, it says the packet, and then transmit opportunity 2 is a different node, but then for transmit opportunity 3, it is still node 1, but it's transmitting using a different node ID. But that's all embedded in a single device. So we have up to 3 node IDs on a single device So that per se, for example, audio is streaming, but I got to burst the audio now, but I don't need it for the second transmit opportunity, but I do need it for the third. So that allows you to jump in and then transmit. And that way it keeps the audio streaming without losing, without false latency. So we provide that in our solutions, and I'll be happy to talk to you more about it in a booth over at 18. And then you must also consider clock centralization. The clocks must stay matched at all times. Setting the clock is clocks used on the years are not all the same and they drift. So you got to make sure that the network not only has a clock, but the clock stays the same. So after synchronization, we spend a update for the clock about 8 times per second. So that's one of the considerations you want to also issue is that the clock is always synchronized. The government requirements for clock synchronizations that are provide can IEEE 1588 provides for clock synchronization as well as 802.1 AS. And that concurs what's called PTP, as I mentioned earlier, which is precision time protocol to ensure that the timeliness of the data. And in some cases, clock synchronization requires large protocols like stacks and also significant hardware support. The edge nodes that are designed can be designed to reduce the cost as well as have minimal hardware and more software support because the edge nodes are designed specifically dedicated for a particular function. So an edge node can be designed for an actuator. Edge node can be designed for lighting. Edge node can be designed for different node that it needs to be, and that reduces the cost in requiring. It also can be designed for to support stamping in the hardware as well as time stamping of events in those events. And in the hardware, I think there's so many things that you must consider synchronization is. You must always have a roll clock, and you must also have accurate time stamping. Now, time stamping must be also considered for the receive, that's a must, but not always for the transmit. Only if there is no mixing, as Mr. said, or there are pairing delays and things like that. It must also consider synchronized event generators or the event time stamping. But in many cases, all this is implemented in a lifestyle of the map in the microcontroller, or in our case, Microchip. We have a landing 63 landing to 651, which is an SPI Mac 5 Mac I 10-2 and that's the best. So in conclusion, single variation that really helps to reduce the cost. It helps to simplify your network, and they can be designed into edge nodes. Again, I got several examples of edge nodes in our booth. It can reduce the need for complex and expensive gateways, and it also has the multi-drop capability, and therefore you can reduce your cost through cable lanes, and efficiency, and you can allocate additional bandwidth to use in PLCA burst mode as well. So overall, Generation 1S significantly helps to reduce and introduce a low latency system. Thank you so much for the time. Any question?
Does anyone have any questions?
What is the latency? I hate to tell you, I don't have the answer on latency, but if you come by the booth, I've got one of our engineers on call that can help me to answer that question. And see, blind drop, what are you for those looking from? It's in folks in there. And I was just never originally, I can barely hear. I still have walking as this one, you have later. All of the film, you just are out there. Was a staying being, can hear. I can't hear this.
As additional devices and then once you got other than correct music, you can
But the throughput, you've got only so many. Oh, yeah. You have 255 cycles on the bus. You do have to be careful in designing for different devices on the bus, but all that spin, you have to architect it. Because again, when you talk about burst mode and things like that, You may only have 4 or 5 devices on the bus, but if you don't do it properly, you can run into latency issues and timing issues. So it just depends on how many that are on the bus and how clever the architect is in designing the bus to support that. But I'll hold such questions because the number can vary. So it just depends on how you architect. So he's been the average of us. 33% for the first. It all loses is because there are distinction barrier. You know, it's been how it can start. You know, the machine now. The spinning are still flat, but they're relatively little person with a few record Western movement. You know, burn harvest and runs the rest of the light. I care about efficiency, burst, and growth. What's really the technology? I don't know what's going on with. I can barely hear you. What I'm saying is, as you have more and more lines, you are going to have flat looking on hands. So we're 15 things look different. Well, so for one time that is 20 in 10 minutes, there's 2 things. Some of that each one is very your size. Well, each one is getting 4. So our plus to the declaration of max. I think that's all controlled by the PLCA and by the node 0 sends out the beacon and there's a period of silence. And then from that, each node gets a transmit opportunity. So it can extend the bus out and cause latency concerns. You just have to architect that. I don't know what was going on with the mic, and I could barely hear what he's saying. With this, again, please stop by 82, and I'll be happy to show you what we have. Also, lots of rollers that I was told that I have to give everything away before I come back. So make sure you come to get a roller, it's nothing else. But thank you so much.
Thing was the change things later. So if you wanted to watch it there and download we will be broadcasting the on your top channel. Yeah, you and both of it.
Thank you so much for your time.